we have observed that concurrent execution of transactions will increase the throughput of the database operations and the response time for the users as well as the transactions. Now, later we observed that the interleaving of the operations to achieve the concurrency may also cause problems as well. And we have observed that any instruction set that involves write operations may cause problems. We have observed that read write or write read or write combinations of instructions by two different transactions on the same database object may create problems that we have seen. Now in this lecture we'll talk about them in detail, and the first one among them is the write read conflict. That is, one transaction has written the database object value A and another transaction is reading a value, the same value of the database object A written by T1. That is called reading uncommitted data. The anomaly is called reading uncommitted data or a dirty read. If you look at the example, T1 is reading the value of A, then writing the value of A. After that, T2 has read the value of A written by T1. And later it performs certain actions and T2 has been committed. But by the time, T1 has not been committed. And T2 has read the value of A written by T1 and T2 is committed, but T1 has not committed yet. In this circumstance, if T1 fails, what happens? T1 has to abort. But the updates given by T1 on A are lost. And T2 has already read the value written by T1 and proceed further and does some action. So this leaves the database in an inconsistent state. So such a read by T2 on database object A written by T1 is called a dirty read. It is going to create a problem in future. Again, if T1 fails, if T1 successfully commits, there may be no problem, but there is no guarantee that T1 will commit. So this may cause a problem that is called a write read conflict or reading uncommitted data or dirty read. This is one of the first anomaly that may creep in if we interleave the operations. The second anomaly that may creep in is called write read conflict, where a transaction writes something which is read by another transaction, and let us see how this will lead to inconsistency in the database operations. In this case, let us say an example. There are two transactions are there, T1 and T2. T1 has read the value of A and T2 has also read the value of the same value of A, and meanwhile T2 has written the value of A. If T2 wants to read the value again, since T1 has written the value of A, now if T2 wants to read the database value again, it may get a different result, because in the first read it has read the value of A which is same as that of the value read by T1, because by the time no changes have been made on A. Whereas if T2 repeats the read action again, by the time in between the write operation of A is being performed by T1, so the value of A is modified. Now in this situation what happens is, if T2 transaction repeats the read actions twice, it gets two different values. That is the inconsistency here. This is called unrepeatable read. That means a transaction cannot repeat the read value again, even without modifying that is the inconsistency in this case. Now, if I perform these transactions in a serial order, in either T2 first and then T1 next, or T1 first and then T2 next, in either of the cases, the anomaly would not be there. Maybe that the value of read by A read by T2 may be different in the serial order, but inconsistency would not have been crept in. That is, both the reads of A by T2 would have been same if the performance of the transactions is in the serial order. Third anomalous behavior is called write-write conflict. That is, one transaction writing the value of a database object which is already written by another transaction and which has not yet been committed. This is called a blind write. That is, without reading what the database object is, blindly the transaction writes some value. This is called a blind write. And let us see an example how this blind write may cause problems for the consistency of the database. In this case, let us observe two transactions, T1 and T2, are writing the values of the database objects A and B. Now first T1 writes the value of A, then without reading the value of B, immediately T2 writes the value of B. After that, T1 writes the value of B without reading the existing value. So blindly it is writing another value of B and then commits. After that, by the time T2 has not been committed. After that, T2 writes the value of A again by not reading the value of A, existing value of A, and then T2 commits. So this is the interleaving the operations of the two transactions T1 and T2. Now let us see as an example, if T1 transaction is writing the values of A and B as 100, whatever the value may be there, but it is blindly writing the value of A and B as 100, and T2 is writing the value of A and B blindly as 200. Look at the interleaved operations of the schedule given by for T1 and T2. First T1 writes the value of A as 100, and then immediately T2 writes the value of B as 200, and T1 again writes the value of B as 100 without reading whatever is there, and then commits, and then again T2 writes the value of A as 200 and commits. The value of A is 200 and the value of B is 100, which is inconsistent. Now this problem is because of the blind write performed by the transactions and interleaving the blind write operations without reading anything. Now if you look at the same schedule as a serial schedule, that is first T1 is performed, then T2 is performed, that is T2 after T1. In that case, the values of both A and B would have been 200, and if the serial schedule is considered as first T2 then T1, the final values of T1 A and B would have been 100. So this interleaving operations of these transactions in no way is consistent with either of the serial schedules. So this is one kind of inconsistency, and this may leave the database in an inconsistent state. So this problem is also called a last update problem, since the update done by one transaction is being overwritten by another transaction.